In many applications of estimation and detection, they have to consider risk and loss function. For instance, in hypothesis detection, you may have two hypotheses. For instance, suppose that you are a medical doctor and a patient comes to you, and you observe some symptoms, some videos, some imaging, and so on. So you have a set of observations, x1, etc., x2, so or a vector x in summary, and then you want to verify another unknown, which is like a hypothesis that is either hypothesis 0, which is the patient has no cancer. Another alternative is to say, oh, the patient has cancer and detect it. So if you so there are four possibilities. One possibility is that really the patient has cancer, and then patient has cancer, and then you detect a cancer. So which is a correct detection of cancer. Another case of correct detection is that the patient has no cancer, and you correctly detect and decide that the patient has no cancer. And these two cases are good, and we want to increase the chance of these two cases. However, there is some cases that the patient has no cancer, and mistakenly you may make a mistake, or the data will mistakenly suggest that the patient has cancer. So there is one type of error. Another type of error is that the patient has cancer and your data and your guess won't show it. So you have another second type. And each of them, there is different cost involved. For instance, if the patient has cancer and then you don't detect it, and the patient goes on not detected, so he will not get the treatment he needs, and then he may die as a result. So the cost is very high. The other alternative is that the patient has no cancer, and then you detect him that he has cancer. So somebody who doesn't deserve to get really bad treatments and be frustrated and so on. So we'll have a harsh life. And this is also costly. But these two costs are a bit different, and we want to put a price on them. Another example, suppose that there is you are in a nuclear reactor, and there is a failure somewhere, and then you don't see the failure exactly, you observe some other stuff. Suppose that you have some imaging, and there is like some screw is not tightened very well, and then there is some noise you observe, so a turbine or something. Suppose that one of the blades of a turbine in nuclear reactor is vibrating abnormally. So if something is broken there, we say hypothesis 1, and if nothing is broken there, we say hypothesis 0. So having all these noises, having these observations, we want to detect. And the price is very different. If something is broken, a failure could be very costly. It could like explode, or it could be millions or billions of dollars. So the cost of one type of error could be millions. The cost of the other one is like you will shut down the reactor and will become several hundred thousands of dollars, as opposed to several hundreds or billions of dollars. So we want to in different problems we have different scenarios, and the type of the errors and mistakes could have different costs, and they could have different risks. So this is why they define a loss function, which is a real function, usually positive, and then they usually reduce the squared error and then put these functions, and then they use the joint distribution and so on, which is out of the scope of this course.